Hello, everyone, and welcome to another Sporties webinar. We're glad you could join us today where we're going to talk about Datalink weather, how to use ADS-B and SiriusXM for safer flights. Thanks for joining us. Going to be an information-packed hour. Going to try to leave you with lots of tips, both on the theory behind Datalink weather, the products you can use, and some practical strategies for flying with this. My name is John Zimmerman. I'll be your presenter today. I work there at Sporty's Pilot Shop right on the runway at the Claremont County Airport in Batavia, Ohio. In that role, I've been involved in the development of a number of these products, including the Stratus and Sentry ADS-B receivers. But more than anything, today I'm going to come to you as just an active pilot who flies with these products. I've been flying for about 25 years. I fly a variety of aircraft from tail draggers to helicopters to turboprops. And that's really my experience that I want to share with you today. I've been using Datalink weather for the last 20 years, both in the panel and on portables. And hopefully I've learned some tips along the way I can pass along to you. So I also do a site called Airfax, which if you haven't checked out, you might want to do that. It's a free website. We do articles from readers and a few that I write as well. But one series we do there is called Go or No Go, and it's all about weather decision making. So if you want to test your weather decision-making skills, I encourage you to check that out. Give you a quick overview of what we're going to cover today. We are going to move pretty quickly, try to cover a lot of territory. We're going to start with the rules for weather flying to try to set the rest of our discussion today in some basics that we can refer back to. We'll talk briefly about ADS-B versus SiriusXM weather and the differences between those and the similarities between those. We're going to talk a little bit about the three key hazards that we can use Datalink weather to avoid and why those matter. And then probably the most fun part, at least for me, we'll end with some real world scenarios where we put some of this theory to use. I'll show you some examples from recent flights where I used these products and what I learned from them. I want to start though with why this matters, because it's easy to get caught up in the jargon and the technology, and this is not just an issue that's for gadget geeks. I really think the smart use of weather technology can improve safety and quite simply save lives. I think there's some data to back this up. This is not just my opinion. If you look at overall fatal accidents in general aviation, and I'm using the AOPA Air Safety Institute's data here, overall accidents are pretty much steady in GA right now. But since 2011, the accident rate and the fatal accident rate for weather accidents has gone down pretty noticeably. I would actually call it dramatically. What happened in 2011? Well, that was the year that portable ADS-B receivers really came on the market and brought Datalink weather to more pilots than ever before. Now, I'm not going to say correlation is causation. I don't want to make too strong a case here, but I think it's at least interesting that this trend took off as more and more pilots started flying with iPads, portable receivers, and had weather in the cockpit. AOPA did a follow-on study, I think maybe motivated by that trend. And a couple of years ago, they looked into pilots flying with ADS-B in. This was a 5-year period they studied, did some really good investigation on it. And what they found is quite simply, flying with ADS-B in is safer. 50% lower accident rate and a 90% lower fatal accident rate if you were flying with ADS-B in. That's pretty compelling numbers there. However, it's not magic. It's not like you just buy an ADS-B receiver and everything automatically goes well. It's a self-service world now. So the days when you could walk in and see a flight service briefer in person are gone. Flight watch, gone. It's really on us as pilots. We have to know how to use these tools. We have more information than ever before. Pilots from 30 years ago would be floored by an iPad running ForeFlight with Datalink weather. But there's more than ever, there's a component that requires us to use those tools properly and to interpret the weather data. So yes, there's a great possibility to fly safer, but I think we have to really take it seriously to use that information wisely. So let's talk about some weather rules. And these are my weather rules. These are not from the FAA. These are probably not comprehensive, but I think it's at least worth considering some of the larger themes that inform your weather decision making. Let's walk through these one by one. First, and probably the boring one, but the important one, is always start with the big picture first. A lot of pilots, and I've been guilty of this myself, you dive right into the radar and the METARs, and you want to start looking at site weather reports. That's really a mistake. I think you want to start with the overall picture, have a theory of what's going on with the weather, and then try to fit the data to that and see if it lines up. I often use the analogy, it'd be like a surgeon going in to do surgery and just randomly cutting on the body. You first want to understand what's wrong with the patient, what problem are we trying to solve? Same thing here, what's driving the weather? Not just what is the current snapshot of weather at my destination, but what might be causing that? To answer that question, I think you start with the surface analysis, which you see here. Where are the lows and the fronts? Those are the real weather drivers for pilots. Low pressure systems often bring poor weather, IFR conditions, icing in the wintertime. Fronts can bring gusty winds. They can bring thunderstorms in the summertime. So get a sense for where those are. Next, I like to look at the upper air analysis charts, especially the 500 millibar analysis. That's about 18,000 feet, and that gives you a really good sense of what things are doing up in the atmosphere. So we fly up there. We care about more than just surface weather. And this is a place to get an idea of the steering currents. These are sort of the weather highways. And if you can look at this chart and sort of get comfortable with it, you'll figure out, are there big lows aloft? Are there cutoff lows aloft, which can sometimes cause weather to just stay in a certain area for days and days at a time. There's nothing there to push it out of the way because it's a cutoff low. So get a sense for where these are, where are the troughs, where are the ridges. You don't need to go full meteorologist geek out on this, but I think a general understanding of what's happening at the surface and what's happening in the upper air can let you know what the big picture is and what's driving the weather. All right, let's talk about the data link delay. This is no doubt something that all of us have heard about. Hopefully, if you've been flying a while, you know about this. Data link weather, no matter where it's from, SiriusXM, ADS-B, it's absolutely delayed. It is not real-time, quote unquote, weather. That does not mean it's worthless, as we'll talk about, but it's worth understanding that it is delayed. The first thing to do is just acknowledge that and make the timestamp part of your regular scan. So if I'm cruising along in flight, I'm checking oil pressure, I'm checking RPM, I'm checking my altitude, make sure I'm on that. Check your iPad, make sure it's still connected to your receiver, make sure you're getting regular updates. That timestamp should generally show a time about 4 or 5 or 6 minutes ago. This is an example here in ForeFlight where you can tap on the timestamp and get more detailed information of exactly when you did get your most recent update. So definitely something to check out. It doesn't have to take long, but just every once in a while, check on that timestamp. Remember, that doesn't show your total latency. So if it says radar was updated 5 minutes ago, that's when you received the weather data. The actual radar scan could be up to 10 minutes older than that because it takes time for the radar to scan the sky, collect all the data, processes it, and then transmit it up. So remember that this weather is delayed. Also remember, there's a difference between when you get the data from a ground station or a satellite and when the actual weather report was created. A great example of this is METARs or TAFs. METARs are typically only updated every hour, usually 5 minutes before the top of the hour. So if it's 2:45 p.m. and your METAR shows almost an hour old, well, that doesn't mean you're not getting current weather data. It just means the METAR hasn't been updated. Garmin Pilot is the example on the screen here, and I think does a nice job of showing FIS-B, which is ADS-B weather, transmitted it 23 minutes ago, but it tells you the observation time, makes very clear that this is when it was observed. And so a METAR may be transmitted a couple minutes ago, but the data itself is slightly out of date. That's okay, just recognize what you're looking at. All right, so recognizing that data link weather is delayed, what do we do with that? What we do with that is we use it for strategic and not tactical avoidance. The goal with data link weather is not to fly up close to a line of storms and pick our way through, find the quote unquote soft spot. The plan is to deviate well before we get to that weather. So use your data link weather to look hundreds of miles away. Make a plan before you get close to the weather. And this has really changed how I fly recently, especially if I'm flying in piston airplane, Cessna 172 at 6,000 feet. I don't want to get anywhere close to weather like this. So I will tap my course line. I will drag it until it's clear of the weather and just simply avoid the whole mess. If I'm IFR, I'll go ahead and change my flight plan. So instead of asking for 20 degrees left and then 10 degrees right, I'll just call ATC and ask them for a new flight plan that takes me well clear of the weather. That's easier on them and me. So far, we've talked a lot about radar. That's often what people talk about when they mean data link weather. But rule number 4 reminds us to go beyond radar. Radar is fantastic, but you need to supplement that with METARs, PIREPs, cloud tops, lightning, all the other weather products out there. And I'll show you some examples here shortly of how important that is. SiriusXM has a ton of weather products, certainly far more than just Datalink radar. ADS-B has also added some recently. If you haven't noticed in the last couple of years, ADS-B has added cloud tops, turbulence forecasts, center weather advisories, and lightning. So there are lots of options to look at here. My final rule, maybe the most important, the eyes always win. So no matter what you're looking at on the instrument in front of you, whether it's a panel display or an iPad, the Datalink display is there to support a decision. It cannot and should not make a decision. That is on you as the pilot in command. And what that means is you should be using your eyes to confirm out the window what you think you see on the screen in front of you. If it's ugly, who cares what the screen says? Avoid it. And the picture on the screen here is a great example. You don't need Datalink weather to know that cloud is bad news. There is nothing that a iPad app can show you that you don't already see with your eyes there. That's ugly, that's bad news, we want to stay away from it. I think that's maybe obvious, but a lot of pilots can back themselves into a corner by relying too much on the product that you're seeing in front of you. So eyes always win. All right, let's take a look at ADS-B versus SiriusXM. These are the two most popular ways, really the only way for GA pilots to get weather in flight. So let's compare and contrast them briefly. ADS-B, if you're familiar, we've been talking for years now in aviation about ADS-B. A lot of talk in 2020 about the ADS-B mandate, which required pilots to install basically an upgraded transponder in their airplane. That's ADS-B out. When we're talking about ADS-B weather, we're talking about ADS-B in. This is the receive part of it. And we receive ADS-B in data from a network of ground stations. And this is the key difference between ADS-B and SiriusXM. ADS-B information is transmitted up from the ground from a series of hundreds of ground stations in the US. That means that you are going to have to be in the air typically to get reception. This is like VORs in the old days, that the higher you get and the flatter the terrain, the better your reception is. So it's line of sight. Here's an estimate from the FAA on the screen of reception at 1,500 feet AGL. So you can think of this as sort of pattern altitude. And you can see that actually it's quite good east of the Mississippi. In most places, you're going to have Datalink weather shortly after takeoff. Here at Sporty's, we're about 40 miles away from an ADS-B tower, and we get weather maybe 200 feet off the ground. As you get out west, obviously, the terrain gets more rugged. You need to be higher. But here's an estimate at 5,000 feet AGL, maybe a typical cruising altitude. And it shows that really you've got coverage everywhere in the US except for a couple of pockets of the high Rockies out west. Now, the downside to ADS-B obviously is you've got to be in the air. There's this line of sight limitation. The upside is it's subscription free. Your tax dollars paid for it. So there is no monthly fee for ADS-B. What do you get with ADS-B weather? Well, pretty much everything that you would expect: radar, METARs, TAFs, pilot reports, winds and temps aloft, airmets, SIGMETs, all the good stuff. We don't need to go through this chart line by line, but there's two pieces to be aware of here, which we'll touch on as we go. One, the radar is broken up into two products. There's a regional NEXRAD radar and a CONUS, or Continental United States NEXRAD composite. The regional is available within about 150 to 250 miles of your airplane. So that's going to be within typically an hour to 2 hours of your flying. The CONUS is available nationwide. The CONUS is lower resolution than the regional. So you get these two different levels of resolution, which I'll show you in a second. The other thing to realize is they're transmitted at different intervals. You will get a regional radar update every 2.5 minutes from those ground stations, whereas CONUS is only updated every 15 minutes. That comes into play occasionally with ADS-B ground stations because there are different types of them. Again, this is just like VOR. There's surface, low, medium altitude. This really doesn't matter for everyday flying. You're going to be flying along with 7 or 8 or 9 or 10 ground stations. You'll have some of all these types. So not something you really care about in everyday flying, but it's some good trivia. And it's also the one place where you might notice, let's say we're on the ground in Lakeland, Florida at Sun and Fun, for example. There's a surface station there right on the field in Lakeland. So great, I actually get ADS-B weather on the ground. The thing to be aware of is you'll notice you only are going to get that regional radar. You will not have nationwide radar. So if you fired up your iPad and you saw X'd out radar over California, there's not a problem. That just means you're only getting one surface station. When you take off and you start receiving more, it'll all fill in. You'll have all your weather data. So that's ADS-B, ground up, subscription free. Let's talk SiriusXM, which is the Pepsi to the ADS-B's Coke. This is satellite based, so it's coming from the sky down. That means it works at all altitudes, even on the ground. You don't have to worry about mountains or line of sight. It even has some coverage in southern Canada and the northern Caribbean. So all across the US, you're going to have coverage no matter where you are. The downside is it's a premium product, so you pay for it. There is a monthly subscription, ranges from $30 to $100 a month, depending on which weather products you want. $30 a month is plenty for the VFR flyer. That's your radars, your METARs, and TAFs. If you really want some of the high-end stuff, icing forecasts and things like that, you're going to pay a little bit more. One other good tip here that some pilots don't realize is you can suspend your subscription one time a year for up to 6 months. So maybe you don't fly a whole lot in the wintertime. You can pause it and only pay for it in the summertime when you're flying more. SiriusXM also, in addition to having that satellite coverage, has some more products available. So as I said, depending on which subscription you go with, you can get additional information like base and composite radar, storm cell tops and movement, satellite imagery, and surface analysis. So let's spend a few minutes briefly on base and composite reflectivity. This gets super geeky in a hurry, and it's really not that important for most pilots, but if you're paying for SiriusXM weather, you should know what you're getting here. Base reflectivity is the lowest tilt from a radar site, and that's actually what ForeFlight labels it in the app. This is basically what's coming out the bottom of the cloud. So the radar scans at the lowest tilt elevation and paints a picture. Composite reflectivity, where the radar is scanning the sky at multiple tilt angles and sort of combines that into a 3D view in the sense that it takes the worst case from all of those altitudes. Typically, that means composite reflectivity will look worse. It'll have more oranges and reds because it's doing the entire atmosphere. That's not a bad thing because as pilots, we fly in 3 dimensions. So if it's okay at 500 feet AGL, but bad at 8,000 feet, I might want to know that. So in general, I think composite reflectivity is the safe way to fly. It's what most pilots fly with. That's what's transmitted on ADS-B. So that is probably the right answer. However, if you're knowledgeable about your weather, you can compare these two products. You can compare base and composite and get kind of a sense for the 3D atmosphere. What's really going on at altitude versus lower to the ground? Maybe you're flying a tail dragger at 500 feet AGL and you don't care what's happening in the flight levels. Well, you can compare base and composite and get a sense for it. ADS-B versus SiriusXM. Let's compare a couple of these features quickly. So again, ADS-B transmits typically data closer to your aircraft. So TAFs, for example, you get within 250 to 500 miles. SiriusXM, you get them nationwide. There again is the radar issue. You've got the 2 radar resolutions with ADS-B, and you have 1 consistent resolution with SiriusXM. Here's that radar. You might sometimes hear, well, SiriusXM radar is higher resolution than ADS-B. That's sort of true, but not exactly. Really, the regional ADS-B and the SiriusXM radar is the same basic resolution as you see here. The difference is SiriusXM is full resolution nationwide. So on this trip, we've just taken off from Denver. That weather up in Minnesota, Wisconsin is hundreds and hundreds of miles away. And on SiriusXM, it doesn't matter. It's all 1 resolution, so it's nice high resolution. ADS-B, on the other hand, you can see here clearly there's 2 different resolutions. Closer to where we are, sort of in the Memphis area, up north of the screen, you got that high resolution, looks a lot like SiriusXM radar. You get down south, though, into Louisiana and Texas, you can see it's blockier. That's that national radar resolution. As you get closer to that blockier stuff, it'll turn higher resolution. So in my experience, this is never really a limiting factor. It's not a big deal. It's just something to be aware of. So that's the basics of SiriusXM versus ADS-B. They're both great products, and the key point is to fly with some type of Datalink weather. The similarities are, I think, more important than the differences there. But let's talk about a little bit of hardware and what the options are. Lots of them. We're going to talk about portables here, as that seems to be the most popular. Almost all of these are good. There's not a bad option here. So I would suggest you think about the app first, because not all of these receivers are compatible with all these apps. So focus on what app you use, whatever it is. You like ForeFlight, Garmin, WingX, Flight Plan Go. Stick with the app and then pick a receiver that's compatible with it. Then think about the extras. Some of these do more than just weather. They'll do flight data recording, carbon monoxide detector. Consider whether that matters. Think about battery life, which if you're a renter or a flying club member might be very important. You want to have plenty of battery life, or for backup. Maybe you're building into your airplane and you don't care as much. And then obviously ease of use and support. So let's run through a few of the options here real quick. First up is the newest one. This is Sentry Plus. This was introduced very recently. New top of the line model from ForeFlight. It works with ForeFlight. A couple interesting features here. It has a built-in screen so you can get real-time status information. You can check battery life. You can check ground speed, connection status. A good way to verify that. It's got the longest battery life by far. It's got an 18-hour battery life, so really convenient. I've done some flying with Sentry Plus, and I can go weeks without charging it. So really handy if you're going back and forth between airplanes a lot. You don't have to worry about charging it as much. It also has a really nice flight data recorder built in. It'll automatically log your flights and automatically sync that with ForeFlight so you can replay flights. Pretty interesting. I've used this for a proficiency flight recently where I could check my steep turns and approaches and see how I was doing on speed and altitude and bank angle. There's even a G meter in here so you can track your Gs. So it again goes beyond just the weather. It also works with onboard Wi-Fi systems, which I don't have, but if you are lucky enough to fly a jet that has a GoGo wireless, for example, it can actually join that network and play nicely with it. Some other ADS-B receivers. Sentry Mini is sort of the basic Sentry, just GPS, weather, and traffic. There's no battery, there's no AHRS, so you have no backup attitude. But at $299, it's an affordable way to get weather and traffic on your iPad. Sentry, the original one, is $500. Like Sentry Plus, it has a carbon monoxide detector as well, which is, I think, a great safety feature if you're flying a piston airplane, especially in the winter where leaky exhaust systems can be a real problem. I've had it happen to me. I think that CO detector is a great feature. Sentry, Sentry Mini, Sentry Plus all work with ForeFlight. If you're flying with Flight Plan Go, WingX, Garmin, FlyQ, there are some options there. Stratus 3 is the most universal. This works with 12 different apps, does weather, GPS, attitude, so it does that backup attitude indicator. And then Garmin also has a line, the GDL line. GDL 50 is ADS-B. This works with Garmin Pilot, Flight Plan Go, and ForeFlight. It also works with Garmin GPSs. So if you have an Era 660 or 760, it can talk to that as well. Now, if you're looking at SiriusXM, that'd be the GDL 51. This is compatible with Garmin Pilot, Garmin GPSs, and ForeFlight. It works with Flight Plan Go, but the SiriusXM weather doesn't, so it's not a great fit there. 8-hour battery life, and a nice feature right now, there's a $200 SiriusXM rebate through the end of the year that basically will pay for your SiriusXM subscription. And then if you want everything all in one, the GDL 52 is the answer. This is SiriusXM and ADS-B plus GPS and AHRS. So the advantage here would be you could have SiriusXM weather for all that premium weather product, but then you could have ADS-B there for traffic or for backup. And just a great all-in-one unit. It's the most expensive for sure, but it's also the one that does everything. So a great no compromise option. Here's a quick comparison, and this is available on our website at sporties.com, going side by side. As you can see, they all do the essentials here. They all do weather, they all do GPS, they all do traffic, with the exception of the GDL 51 there. So, those are the key features. Ask yourself what matters beyond that. Do you want AHRS for backup attitude? Do you want a CO detector? Does battery life matter? And again, look at that app compatibility. All right, so we've covered the basics of these systems. We've covered some of the hardware. Let's assume now we've made our choice. We're flying with one of these. Let's put it to use. And let's start with avoiding the 3 key hazards, which are IFR conditions, thunderstorms, and icing. And these are the 3 key hazards to me because these are frankly what kill pilots. And if we want to really focus on improving our safety, we should focus on what the data says. And what the data says is that avoiding that classic VFR into IMC, a VFR pilot stumbling into clouds or fog, that is still the #1 cause of weather accidents and almost always fatal. So that should definitely be up there. Thunderstorms is another big one. And we talk about a lot with Datalink weather, but it is important. Unfortunately, thunderstorms do cause fatal accidents. And then icing. So if you can cut these 3 types of accidents, you've cut your weather accident risk by 80%. So it really have a serious impact if we think seriously about these three things. Let's start with IFR conditions. And I want to go back to weather flying rule number 1, which is know the big picture. It's easy to get locked in looking at a METAR and say, well, it's VFR according to the little circle in Garmin Pilot or ForeFlight. But you really ought to start bigger. One simple way that I think not enough pilots do is the visual map of METARs. So don't just read text weather reports for your airport. Almost all these apps allow you to turn on a map layer where you can see a visual representation of the METARs. This is a great way to get an at-a-glance view of what am I really looking at? Is there one airport that's in a river valley and it's got fog, or is this widespread and everything's IFR across the whole area? It can give you a real good sense of trends for where the weather is across a larger area. If you're flying with SiriusXM, you have that satellite imagery and the surface analysis. Make sure to use those. You also have pilot reports. This is not just for turbulence and icing. Pilot reports often are very good about letting you know where the tops are, where the bases are. So use all those to get a big picture sense. Of course, at a certain point, you do want to go get into the text of a METAR. That is for staying VFR, that is essential. And I think you want to be fluent when you read your METARs. All these apps do a great job of decoding the METAR and telling us the basics like winds, visibility, clouds. That's great. But if the weather is really marginal, or if you're IFR and you're trying to decide whether you can make an approach or not, I think you need to actually go beyond just the headlines there. Here's an example. Being a weather geek can pay dividends. Here's an example of a METAR from Cincinnati, just across the river from Sporty's here, and light snow falling 3 miles, visibility, light snow, mist, temperature -3. So this is obviously an IFR day. This is not a great day to fly, but depending on the kind of airplane you're flying, perfectly safe. You know, Cincinnati has 6 different ILS approaches that go to 200.5. So this is well above minimums. No problem, right? Here we go. I'm IFR current. Well, if you read the second line, which is all that stuff that we tend to skip, and I certainly do this myself, but if you dive into that, you'll notice there's some pretty important notes there. Freezing drizzle just ended a minute ago. There's no ice accumulation, but there is 0.14 inches of ice accumulation in the last 6 hours, and the temperature is below freezing. So it's very possible that you have slick surfaces on this airport. That to me makes me reevaluate how good this weather report really is. So this is an example where going beyond just the headline can help for staying out of IFR conditions. You don't always have to have this memorized, especially if it's pre-flight. Use Google. You know, you can search this. There are METAR decoding sites out there that are free. But at the very least, maybe get to know a little bit of what some of these mean, because if it's marginal, I think this can make a big difference. One other final thing on IFR conditions is rain is not your friend if you're a VFR pilot. Sometimes, you know, the rain comes through and you say, well, we'll wait out the rain, and once the rain's through, we'll leave. That can sometimes work, but rain has a way of creating its own weather. So rain, if it really saturates the air, often can cut visibility just by itself, can cause low-level scud, especially if it's sort of light scattered showers that seem to hang around. Here's an example on the screen. The rain has moved off to the north by over 100 miles, I believe, here, and yet it's still 300 overcast, mist 3 miles. So just be aware that rain is not your friend if you're a VFR pilot, and it can trash a good TAF. If the TAF says, oh, it's going to clear up, but it's been raining steadily and it's kind of misty, that may be your clue to be a little suspicious of that forecast. Next, let's talk about thunderstorms. And this is what most people think when they talk about Datalink weather is radar. Help me avoid thunderstorms. Obviously a great idea. But here's a good example. So here's a screenshot from a trip I was flying, and you look at that screen and you say, would you fly through that yellow? Many pilots might say, no, that looks ugly. I would say you don't know enough to make that decision yet. All you have is a radar screen here, and you really don't know whether that's safe or not. The key question we're trying to figure out often with radar is it convective? Because remember what radar says. All radar does is reflect moisture in the air. It's going to reflect raindrops particularly well. So what that's telling us is there's precipitation. It does not tell us if it's a thunderstorm. It does not tell us if there's wind shear. We're trying to figure out is it convective? So to analyze that, I think we need to go beyond just the classic red, bad, green, good. I try to remember this with the word SIGH, S-I-G-H, because that's honestly Often the words that come out of your mouth when you see a radar image like this, you sigh and say, can we make it? Well, the sigh reminder is to look at 4 different things. First is shape. The shape of a radar return does matter. Are there any hooks or bows or ugly looking shapes? We've probably all gotten used to seeing on TV what a really nasty line of thunderstorms looks like. And you can get a sense for that shape. The I is intensity, and this is what we all think of. Red is bad, green is good. So that certainly counts. Keep that in mind. G, I think, is very important, which is gradient. How fast does it go from green to yellow to red? You can see 2 examples here on the screen. On the left screenshot, that front is really a squall line, and it goes from nothing to red in the matter of a mile. That's a very steep gradient. That suggests real convection. That suggests a bad ride. That's ugly. You're not going to fly through that in anything. On the right side, we have plenty of rain, but it's mostly green, a little bit of yellow, and it's a very shallow gradient. It goes from light green to darker green to lighter yellow to darker yellow. I can tell you I flew through that and it was perfectly fine, just a little bit of light rain. Again, you can see a very stark difference here that tells you one's convective, one's not. The final piece, if you have SiriusXM, is height, which is what are the echo tops. SiriusXM will show you whether the tops are at 20,000 feet, suggesting probably just rain, or if they're at 50,000 feet, suggesting serious thunderstorms. So put all those together when you're looking at radar and go beyond just the colors. One thing on color, though, is understand there are different levels of green depending on the source. This is from ForeFlight, so you can see that at 35 dBz, if you're getting that from SiriusXM, that's going to be yellow. If you're getting that from ADS-B, that's still going to be green. There is a way to normalize this if you want. You can turn on 4-color radar, and this works pretty well. You can see it takes everything to yellow at 30 dBz, everything to red at 40. I think this is a good thing to play around with, although to me it tends to overstate things a little bit. Here's an example where you can see 4-color radar on the left, and there's a lot of yellow and red in there, and on the right there's not as much. So it certainly doesn't hurt to be conservative and play it safe. I find that it tends to overstate things a little bit, so I will compare. I'll turn on 4-color radar, then kind of go back to the other, but play around with it depending on how you fly. It may be a value for you. You can find this on the maps page. Tap that settings gear symbol at the top of the page, and you can turn on 4-color radar. The other thing that people overlook a lot with thunderstorms is go beyond just that radar. Again, this is that weather rule we mentioned earlier. Find supporting evidence. Lightning, pilot reports of turbulence, METARs even. Is there a thunderstorm reported over the airport? Cloud tops. Use all those tools to really figure out whether something's a thunderstorm. You can see here, lightning report. So we've got purple, we've got a steep gradient, and we've got lightning. That's a pretty good sign we've got a thunderstorm there. One final thing on thunderstorms is it's nice to use that ruler tool, which most apps have. You can tap 2 fingers on the map at the same time and measure the distance between 2 things. This can be nice for measuring the distance, say, between 2 lines of storms. This is helpful, but don't be too literal here. That is to give you a rough approximation of, do I have 10 miles or 100 miles between these storms? You should, again, not use this for close-in deviation. You should not be picking around storms with this. Our final one is icing, our final hazard. And again, let's go back to weather rule number 1, know the big picture. The really big picture here is icing is much more common in Seattle or Cleveland than it is in Phoenix or San Antonio. That may be obvious, but I think it's important to start there. Sources of moisture lead to ice, right? The flow of moist air off the Pacific Ocean makes icing in Seattle more common. The Great Lakes are a great ice factory. Think about the type of clouds you fly in. Are these wet clouds, dry clouds, so to speak? Wet clouds typically have more icing. Think about the low, again, the big picture. Typically, if there's a strong low pressure system moving through, the east side of a low is going to be your worst icing. Doesn't mean you can't get icing on the west side, but if you have your choice, the east side is usually going to be worse. And then remember inversions. Is there a temperature inversion that could lead to freezing rain? Once we dive into icing forecasts, those are available in all the apps. This is from ForeFlight. This is actually pre-flight here, and you're looking at 2 options. You have US or global. US is a short-range model, goes out to 18 hours, a little bit higher resolution. The global one is updated 4 times daily and goes out to 24 hours. Both of these give you a sense of where is the icing at different altitudes. So you can use the slider bar at the bottom of the screen for time, the slider bar on the right side of the screen for altitude, and play with different scenarios here. Is there icing at 6,000 feet, 8,000 feet, 10,000 feet? Is there icing now? Is there going to be icing in 4 hours. This is also available in flight. You've got that icing forecast layer. Remember, it's a forecast, so this is not an actual report of icing. This is not like radar, but it can, again, give you an idea of different scenarios. It's available on both ADS-B and SiriusXM, every 2,000 feet from 2,000 feet to 24,000 feet. Give you a sense of, am I going to be on top or below it? And remember, this shows probability when it's in flight, not severity. So this is not light, medium, heavy icing. This is what are the chances you're going to get icing. The other tool that's helpful in flight when you talk about icing is Cloud Tops, which is now available on both services. Again, a forecast tool on ADS-B here. This is not an actual observation. And it's also not precise to within 20 feet. So if it says the tops are at 6,000 feet, that doesn't mean there won't be a cloud at 6,200 feet. But it gives you a general idea. And this is the screenshot we have on screen here. You can use the slider on the right side to say, where do the clouds basically end? And are they low level? I could be on top by 5,000 feet, or do they go up into the flight levels and there's no hope of me getting on top today? Use those tools to get, again, that 3D view of the environment. Often that's the way icing goes. Icing rarely happens over 10,000 feet. Usually it's contained within 3,000 or 4,000 feet. So if you can find an ice-free altitude, either below the clouds, on top of the clouds for a long cruise flight, that's the way to do it. And of course, PIREPs, probably the most valuable thing when it comes to icing. Seek out PIREPs, give PIREPs, be a good aviation community member. But remember to read a PIREP with a little bit of discretion. There are many things that can affect the quality of a PIREP. Number one, how old is it? If it's 2 hours old, the atmosphere may be completely different now. Number two is the airplane type. Moderate icing in a Cessna 172 can be bad, but moderate icing in a Boeing 767 is really bad. And if you're in that Cessna, that's a bigger deal. Climb versus descent, again, that Boeing in a descent where it's going really fast and it's still got moderate ice, that sounds pretty serious. But go beyond just that light moderate, because a lot of times that's just one pilot's opinion. Look for commentary. Tap on the PIREP symbol to see if there's any comments. There's often some pretty good ones, like you see on screen here. A citation reporting that the heated windshield could not keep up with the ice. Well, that's definitely moderate ice. That's something, if I'm in a Cirrus, I want no part of that. So go ahead and read those details. The final piece, though, is remember that a lack of icing PIREPs does not mean a lack of icing. Maybe it's just the weather's so bad nobody's flying. So go ahead and be a little suspicious of that. But that's also why giving a PIREP is important. And so I encourage you, sometimes the most valuable PIREP you can give is a negative. People tend to always report it when they get moderate ice, but sometimes it's really helpful to give a negative ice PIREP. Hey, I was cruising along at 9,000 feet, smooth ride, in the clear, no ice. That might help the next person make that go, no-go decision. All right, let's close with some real-world scenarios. Let's try to apply all this information and put this to use. These are my experiences. Again, there's room for interpretation on some of this, but I'll share what I did. Some I'm proud of, some I'm not as proud of, and what I learned from them. First one here is a long trip. This is a trip from Cincinnati out to Las Vegas, so an all-day flight. And this was the view on the radar, pretty ugly. There were 3 different lines of what looked to me like convection. So I was pretty bummed about this because it looked like this trip just frankly wasn't going to happen. But then I caught myself and I said, well, wait a minute. The goal here is not to fly directly over St. Louis, Missouri. The goal is to get it from Cincinnati to Las Vegas. And who cares if we go direct or not? There's no bonus points for that. So instead of canceling, we just took what Mother Nature gave us. And that might be the best overall rule. Take what Mother Nature gives us. And this day that meant flying almost due north on takeoff and going all the way around the northern edge of this system. We ended up having a great flight, logged a little bit of time in IFR, but had no ice, hardly a bump, nothing more than very light rain. And we did it by just being patient. And I can tell you that when you do this in flight, it feels like you're flying all over the earth. It feels like you're adding hours to your flight, and it's never as long as it feels like. I've done this many times now where I land and I say, gosh, that must have added 45 minutes. And a lot of times you look at FlightAware and it added 10 minutes probably over direct. So go ahead and take that deviation, be creative on routing. When in doubt, this is a different flight, but a recent one that I think drives it home. If you have the choice, deviate on the upwind side of weather. It's not always a guarantee, but if you have that choice, in this case, the weather was moving from the northwest to the southeast pretty quickly. And so if you have that choice, come around the backside. You'll usually have a smoother flight. If there's any hail or anything from one of those nasty storms, it'll probably be shooting off downwind. So again, not a guarantee, not an excuse to be stupid, but fly that upwind side if you can. So the lesson from this flight, go around the weather. Don't pick through it. You know, my first temptation was let's find a hole through all those lines. That's foolish. Use the big picture, know what we know about what's going on in the atmosphere, and just go around it. Change the whole flight plan. We changed every last part of that flight plan, and it was a much less stressful flight than trying to weave and wind through the different lines of it. Scenario 2, slightly different one. Here in this case, we're coming from South Carolina back to Cincinnati. It's a summer day in the southeast US, which means pop-up storms are everywhere. I call this popcorn season because after about 1 o'clock in the afternoon, all those cumulus clouds start popping. Some of them turn into thunderstorms. There's not a wall of storms here. We just have a bunch of isolated ones to pick around. And that's really the way to do it. We're going to stay visual on this flight. We're going to miss the clouds. And we're going to use Datalink weather to inform those decisions. We're going to use that to make sure we have an out and pick which way to deviate. So here's what it looks like, right? You've probably flown on a day like this. Great visibility, but lots of white puffy clouds. And in this case, my goal was get above the haze layer so we have good visibility and a smooth ride, and then just weave and wind. I call it canyon flying because you're just flying around the clouds. Whether it's on the radar or not, you don't want to fly through any of these because they're at the very least building cumulus, and they're probably going to give you a pretty good jolt. So in this case, I was IFR, but I never logged any IFR time because the goal was stay visual. And then you can use the Datalink weather to make sure you know there's nothing around that next cloud. Make sure you know the big picture, and most importantly, make sure you always have an out. And so this was that weavy, windy flight, just left, right, take what Mother Nature gives you. And you can see we had huge gaps between this stuff. So while on the radar, maybe at first it looked ugly, honestly, it was a pretty easy flight. So the lesson here, find out, is this convective? Am I dealing with convective stuff or just rain? And if it's convective, we're going to stay visual as much as possible and use radar as a backup. And I really think of this as flying the trip as a series of 50-mile flights. We're kind of going airport to airport almost of, all right, we have a good gap here. We're going to stay visual. If we don't like what we see there, we have an airport we can land at. All right, we made it there. We're going to do another 50-mile leg, and you can break up the flight that way. It's a great way to make sure you always have an out. Scenario 3, this is sort of the opposite end. We went from kind of basically a good VFR day, but just with pop-up storms. Now we're in a crummy IFR day. It's wintertime. There's a low moving in from the west. I fire up the radar on the FBO in Pittsburgh, and it looks pretty gross. There's rain everywhere. There's a whole bunch of PIREPs. It doesn't look like a great day. And I'm thinking because it's winter and because I'm east of the low, like I just said, icing is on my mind here. I'm thinking icing is not my friend today. Well, I was pretty pessimistic, but I started digging into the data and I started really trying to figure out what's going on. First of all, look at satellite imagery. How thick are those clouds? You know, that's one of the things you can get a sense for. Is this just a thin, wispy, high-level stuff, or is this really thick with some vertical development? Go to those forecast icing charts. Look at the PIREPs. Look at the METARs. Where are my outs? What is the temperature on the ground? Are my airports along the route above freezing in case I get in trouble? Well, what I found is that actually there's a lot of reasons for optimism here. Yeah, there's lots of ice in those clouds, but it's all above 12,000 feet. Both the forecast and the pilot reports supported the fact that icing was all high level. Tons of rain for sure, but it's almost all green, just a little bit of yellow with a shallow gradient and no lightning reports anywhere. And you start digging into the METARs and you realize, yeah, there's a lot of rain, but it's all high level clouds. The ceilings were all 9,000 feet and above for the most part with really good visibility and just light rain underneath. So here's an example where the screen actually looked worse than the weather was. And the more I dug into the weather, the more I realized this was a perfectly flyable trip. So we had a great trip, no ice, just light rain. Honestly, we're VFR most of the time. And this is just a great reminder to use all the information. You know, one look at that ForeFlight screen, you see the radar, you kind of, your heart sinks. But go beyond just that radar and look at all the other products here. In this case, METARs, pilot reports, icing forecast, all filled in the picture. And again, we always had an out, so we were quite confident launching. Scenario 4, we're going back to VFR. In this case, I was flying in a helicopter, so VFR is the only option. There's no way to go IFR here. And we're going to do it low level because in a helicopter, we're generally no more than about 1,000 or 1,500 feet above the ground. I'm going from Tennessee back to Cincinnati. And I turned on the METAR layer and I thought, oh, this looks pretty good. You know, a couple drops of rain up north there, but barely visible. METARs are green, 6,500 feet overcast, no problem. Lowest ceiling was 3,600 feet, which for in a helicopter is plenty. Well, this is one where I hadn't really done enough planning. I was probably in a hurry to launch. I was headed home. And what happened is I took off and I was over the hills of eastern Tennessee, and all that light rain, and it was super light, but it was just enough to kick up some scud. And in particular, the scud was in between METAR sites. So while, yeah, the airport was reporting good VFR and 3,600 foot ceilings, guess what? Weather happens in between airports. And there was some decidedly marginal VFR weather in between those METAR sites. So I had kind of over-interpolated. I said, well, I got two METAR sites. They're both VFR, must all be VFR. Well, I'd forgotten to look at the big picture. And the big picture is rain plus hills plus a close temperature dew point spread usually means there's going to be some scud, and that's exactly what it was. Now, the one thing that saved me here is I had done enough planning to have an out, which was lower terrain and really good VFR to the west. So as soon as I got over the ridges and saw this ahead of me, it was bailout time, head out to the west, and I had a perfectly fine VFR flight home. But I was really kicking myself because I had ignored my rules, I had shortcutted things, and it almost got me in trouble. So the lesson, again, go beyond those site METARs. Use the other map layers. Try to figure out how widespread the weather conditions are. And most importantly, as always, use Datalink Weather to give yourself an out. All right, one final scenario here, and then we'll leave some time for your questions. This one is an old one, but it's still a great exhibit for how to use rule number 5. So I was coming back from the West Coast and looked like really ugly storms to the south of my route. You can see here, really sharp gradient, purple. I mean, that's nasty stuff. We're not going to fly through that. However, looked like a huge hole to the north, right where my destination was. So I was really quite optimistic here. And we started getting closer, and maybe some stuff was starting to pop up a little bit, but there's still a really good hole here. So I was really quite confident. So no problem, big hole. Here we go, Datalink Weather for the win. Well, that's the hole as seen from the pilot's seat. And yeah, there's blue through there, and yeah, you might fly through there and be okay, but I had no interest in finding out. That looks ugly to me. That looks almost anvil-like. So I was definitely not going to fly through there and find out. So that's an example where it looked fine on the Datalink, but I need to confirm with my eyes, and my eyes tell me I want no part of that. That might close up at any minute. So I asked ATC to deviate well around to the north of it. We made it fine. Again, this is an example where I might have added 3 minutes to the flight for a sure thing. But that's one where you can't let Datalink Weather talk yourself into it. And the lesson there, rule number 5, your eyes always get a veto, no matter what it looks like on the screen. If it looks ugly, assume it is ugly. I'm going to give you a bonus here because sometimes when we talk about Datalink Weather, it's always in the context of canceling flights of, oh, well, it saved me, but I didn't fly. The more I've flown with Datalink Weather, the more I've come to appreciate it can cut both ways. You really need to focus on the information, use all the tools to make a smart decision, and cancel is not always the answer. Sure, better safe than sorry. When in doubt, don't. But this is an example of another trip coming back from the West Coast. And in this case, I was in a Pilatus, so high performance airplane, but we were descending. So honestly, this flight would have been the same in a Cirrus at 10,000 feet. And as we were far out, that ADS-B weather, that's that national picture, just a whole mess of stuff. It really looked pretty ugly. I wasn't too optimistic we'd make it. But I made myself kind of do the homework, mostly because we had nothing else to do but trudge on and keep watching it. And first of all, you start to get that regional radar. It gets a little more precise. You can dive into the details. You can look at METARs. You can look at pilot reports. And what I realized here is Datalink Weather, in this case, made this flight doable. Far from making it, a cancel decision, this gave me options. And this was really the picture. Yeah, there were tons of storms around, but they're all pretty widely scattered, and there were big 30, 40-mile holes between these lines. And as we descended, we just sort of weaved our way around these buildups. Again, stay visual. And I landed saying this flight was only possible because of Datalink. I probably would have canceled or at least landed short beforehand. And so in this case, I thought Datalink Weather sure kept me safe, but also helped me complete a trip. So to sum up, these are the 5 rules that I follow. Know the big picture. Start out with that theory of what's really going on. Remember the delay and check that timestamp. Use Datalink weather for strategic, not tactical avoidance. Change your route, don't deviate through embedded thunderstorms. Go beyond that radar, use all the other information you have available. And remember, your eyes always win in the end. That is the final check. So I think of it like this. I almost think of it as like a funnel. We start with the big picture, and that kind of gives us our context. Then we look at the Datalink weather, which gives us closer to real-time information, what's actually happening. And then it goes down to the eyes for kind of our final filter at the bottom. But you are the pilot in command, so it's up to us to make that decision. And I'll close with a quote from Richard Collins, a fantastic aviation writer I had the honor of working with for many years. And he wrote this once, and I thought it was absolutely wrong the first time I read it. But over the years, I've come to believe it's absolutely right. He said, "Nobody gets trapped by weather. There are always signs." And I think that's really true. If you're honest with yourself and if you look hard and you use all the tools, there are signs. We just have to know how to read them. With that, I want to save some time at the end for questions. So if you've got some questions, please feel free to type those in. We'll try to get to as many as we can. So here's just a tip from somebody that's a great point, which I didn't cover, which is you can absolutely animate the radar. So if you're flying along and you want to know which direction is, say, the upwind side to deviate around, almost all these apps have the option for you to hit the play button. If you've had your receiver running for a good 20, 30 minutes and you've got multiple frames, hit the play button and animate, get a sense for which direction it's moving and how fast it is. Let's see. Question here about ADS-B and for-flight subscription levels. Do you need a specific for-flight subscription to show different ADS-B products? The answer is no. All those weather products are available on the Basic Plus subscription. The only minor detail is if you want synthetic vision. So if you had a Stratus or a Sentry and you wanted that synthetic vision with backup attitude, the Stratus or Sentry will show you backup attitude by itself. But if you want that 3D view of the terrain and obstacles, that requires synthetic vision, which you want to make sure that is part of your subscription. Question here, is it safe to fly under the anvil of a thunderstorm? I would say no. You know, this is one of these, there's no absolutes. You could probably get away with it, but I would certainly not recommend it because that's a great place for hail or wind shear and really severe turbulence. So I would always avoid that just to be sure. Question about some of these receivers, do they allow devices for a Wi-Fi hotspot? The answer is no. These use Wi-Fi to connect. So the Wi-Fi is really just a short-range data connection. And so you're not going to use that to connect to the internet. There's no internet connection here. There's no data connection. It's simply transmitting the weather data from the receiver to your iPad over short range. Question here about winds aloft when flying with ADS-B weather and for-flight. Yeah, good question. So for-flight has this very slick winds aloft map layer. And that's really neat, but it's only available on the ground. The winds aloft data you get over Datalink, you'll get in textual form. So for example, if you tap on an airport, you've got the METAR and the TAF option there. You've also got winds and temps aloft. Tap on that to get your in-flight winds and temps aloft. It's the same information, it's just the app does not display that visual display on the app. Question here, is there a way to look at the history of weather to check a trend? Well, that Animate Radar is definitely one of them. If you want something on the ground later, there are some websites out there you can actually get historical weather. You can Google that if that's what you're looking for. Question on Garmin receivers, do any of these monitor carbon monoxide? Unfortunately, they do not. The only ones with the CO detector are the Sentry and the Sentry Plus. Question here about MOS, model output statistics. MOS is a great forecast. This is basically a numerical forecast that predicts for many sites beyond just the airports that have TAFs, and it also goes further in the future. So MOS is a great forecast tool, but it's not available in any of the Datalink services that I'm aware of now. That's going to be a pre-flight tool. All right, somebody's trying to pin me down. The question, if you had to choose ADS-B or SiriusXM weather, which would you choose? I don't really think there is a right answer for everybody. It kind of depends on what you are flying and what kind of equipment you have. So for example, if you were flying a tail dragger VFR and you're flying 50 hours a year, I think ADS-B is perfectly fine. You're going to get radar, you're going to get METARs, TAFs, pilot reports. That's going to be everything you need, and you save the subscription. Now, if you said you're flying a a jet, you're flying a Cirrus jet or a TBM, something where you're going fast, that's where that SiriusXM can pay off. You're going to have more weather features. You're going to have that nationwide radar, where if you're going 300 knots, you maybe want that full resolution radar across the whole US. So I think it does depend on what kind of equipment you're flying. Are you VFR, IFR? I will say in general, ADS-B seems to be more popular just because it gets you all those key features with no subscription. So when in doubt, that's probably the answer. But if you're flying Canada, you're flying low altitude, or you're flying a high performance airplane, that's where SiriusXM can really pay off. A question here, will the Garmin GTX 345 link to an iPad running ForeFlight? The answer is yes, it will. Very good way to get a built-in ADS-B receiver. The GTX 345 is a panel mount ADS-B out transponder and ADS-B in receiver. How much distance do you keep between you and a pretty hot storm, say one that is topping 40,000 feet? Yeah, it's hard to have a hard and fast rule there. Generally, if it's really convective, if it's got lightning, if it's purple, it's above 40,000 feet, I give it a pretty wide berth. I'm not sure there's a magic number. You'll hear different numbers thrown about, 20 miles, 40 miles. Better safe than sorry. I think actually the most important thing that gets overlooked is I was once told that if you have a big cell that has purple in it, really serious stuff, and it's got lightning and it's topping out at 50,000 feet, you should avoid that whole cell. In other words, don't just miss the purple part, miss the whole cell, because probably that whole cloud is ugly. So that's an example where you want to give the entire thing a wide berth. And I will, as much as possible, stay visual there. I will not try to just pick the soft spot. I'll try to actually, even if I'm IFR, try to stay out of the clouds, because that's sort of my way of assuring I have a smoother ride. What's the best place in the airplane to mount a Sentry unit for best reception? Best answer is a side window. Sentry comes with a suction cup, so really the best place would be on a side window using that suction cup mount. That gets it a great way to see up for GPS and down for ADS-B. Question about comparison chart. Yeah, there's a couple great resources. One I'll point you to is iPadPilotNews.com. That's a free website we do. We cover iPad apps. We also cover weather receivers. And that we just recently did a great portable weather receiver buyer's guide that lets you compare all the features side by side. So I would definitely check that out, iPadPilotNews.com. There's also an email newsletter you can sign up for there. Is ADS-B available outside the continental US? No, unfortunately, it's only US. There is a station down in Puerto Rico, so you have it down there, but you will not have ADS-B in Canada. Once you get about 25 miles north of the border, you will not have ADS-B in Mexico or the Bahamas. It's US for now. Some countries are talking about adding it, but I don't think anything there has really gotten too far off the ground. Question about composite versus base reflectivity radar. Which one is available in ADS-B? ADS-B shows composite reflectivity, which is, again, I think the right answer. That's the more conservative one. SiriusXM gives you both. Do any of these apps offer SKU-T data? Good question. None of them do. SKU-T is a somewhat complicated looking plot of temperature and winds and dew point. Once you know how to read it, it's a very, very powerful tool. It's not transmitted on any Datalink services, and it's not available in any of these apps that I know of. There are some specialized weather apps out there where you can find that, and once you get to know how to use that, that's very useful. But I would say SKU-T, once you get to know it, it's great, but maybe spend a little time Googling to understand it. It can be a very powerful tool. With that, everybody, we are just about to the top of the hour. We're out of time. Thanks for your attention. Thanks for your great questions. Again, iPadPilotNews.com. You can get some more information on this, and my email's there on screen if you have questions you want to follow up with. Thank you very much for attending today. We hope to see you again for another Sporties webinar soon. You can check out sporties.com/webinars for our list of upcoming ones. Also check out our YouTube channel. That will have a video recording of this presentation, and it has a video recording of all our webinars. So it's a great resource. Thanks very much for joining us, and fly safe.